First order and second order filters are far more than academic exercises. They're essential tools in modern electronics, shaping signals, protecting circuits, and enabling communication, control, and precision. By mastering first order filters, you gain practical skills that are directly useful across a wide range of real-world applications. The concepts you're about to learn will not only help you in designing circuits, but also deepen your understanding of how everyday technologies around you operate. First order filters, despite their simplicity, are used everywhere because of their efficiency, low cost, and reliability. In many cases, a first order filter is the best solution. It performs the needed function with minimal components, low power consumption, and minimal design complexity. So in this part of the course, I just wanted to talk about some key reasons why learning first order filters is well worth your effort. Many practical circuits use first order filters as is without any modification. Now, understanding first order behavior is essential even when designing more complex and higher order systems. When size, power, and cost matter, which almost always they do, first order filters are often preferred. Now, second order filters certainly have important applications, particularly when more precise or steeper filtering is needed. However, they build on the same ideas you're about to master by studying first order filters. Towards the end of this course, I'll show you how to build second order filters based on everything you learned in the earlier parts of the course. Now let's have a look at some real-world applications of first and second order filters. A good example is in audio applications. When you adjust the bass or treble controls on a music player, simple first order filters are shaping the sound. Capacitors and resistors modify the balance of low and high frequencies to match your preference. In sensor inputs, for example, when you have an Arduino that reads a temperature sensor, which can contain noisy signals due to environmental interference or a noisy power supply, then you can use a small RC low-pass filter with just a resistor and a capacitor, which can significantly improve the quality of the sensor reading that eventually goes to the Arduino. In motor control, when controlling a motor's speed with PWM, pulse width modulation, a first order low pass filter can smooth the voltage and prevent the motor from producing audible whining noises, which affect, of course, efficiency. Wireless systems. Now, before transmitting or receiving wireless signals, circuits often include filters to ensure that only the desired frequencies are used. First order filters can remove simple spurious signals, while second order filters are sometimes used for tighter frequency control. While first order filters are sufficient for many tasks, second order filters are valuable, as I mentioned earlier, when we need things such as a sharper transition between passed and blocked frequencies, when we need higher selectivity, such as isolating a very narrow frequency band in communication systems, for improved stability and control over gain and phase when these are critical, such as in feedback control systems. Learning second order filters becomes natural and much easier once you are confident with the concepts and behaviors of first order filters.